really quickly this time. Apologize for the delay last time.
All right.
So the limit as b goes to minus infinity. You have to write that in front. That's part of this, like, do you have an instructor that wants you to write this full notation? And this is the integral from 0 to b, limit as b goes to infinity, x e to the minus x squared dx.
Yeah, we do have to write it like that.
And you have to write all this. It's kind of back to that, definition of the derivative. It's horrible. Okay, so your antiderivative here is e to the minus x squared. Okay, now when you take a derivative of this minus x squared, remember you got a minus 2x out in front, but we only want an x. So you put minus 1/2 here to take care of the U-substitution part of this. So like you want to be able to take the derivative of this and see that it gets you back to this previous line.
Okay.
Do you see that? Is that okay?
Could you just re-explain it?
The derivative of e is itself. So the derivative of e gives you e to the minus x squared. The derivative of minus x squared is minus 2x. Minus 2x times minus 1/2 gives you just the x.
Where's the 1/2 coming from?
So let me come off the side here. So if I tell you y equals minus 1/2 e to the minus x squared, y prime is minus 1/2 e to the minus x squared. But then you have that chain rule part, right? You have to take the derivative of minus x squared. That's minus 2x. So your derivative is minus 1/2 times minus 2. That gets you to 1. X e to the minus x squared. And that's back what we started with. If you're really uncomfortable with what I just did, we have to do a U-substitution. We can do that.
Okay.
Would you like me to do that?
Yes.
Okay. So we're gonna we got to kind of come off to the side here. We're going to come back to this line, but let's just say we want to integrate x e to the minus x squared dx. So your u.
Why are we taking the derivative of it? I thought we were supposed to be taking integral.
I'm trying to show you you start from the answer and work backwards to get it. It'll make sense here when we're done. Okay. So the u is minus x squared. Du is minus 2x dx. So this is the integral x e to the u. Dx is du over minus 2x. Is that okay? Is that comfortable? All right. So the x's cancel, and you get negative 1/2 integral e to the u du.
Okay.
What is the antiderivative of e to the u? It is itself, right? Plus c, but u is minus x squared. So your minus 1/2 e to the x squared plus c is your final answer.
Okay.
So what we just did there is going from we're going from this line. We got to be able to integrate this x e to the minus x squared. So that I know I just went by it here, but this minus 1/2 e to the x squared is the integral of this right here, and that's what I'm trying to show you. The derivative of this line is that down there.
Oh, right. Okay.
Okay. But that's not necessary. So what is necessary though is for us to write minus 1/2 e to the minus x squared evaluated from b to 0, limit as b goes to minus infinity. Plus, and thank goodness this is similar, limit as b goes to infinity minus 1/2 e to the minus x squared from 0 to b. So all I did, just to be clear, is I wrote the limits that we're going to evaluate this integral at, and then this limiting stuff out in front.
Okay.
But we're not done so much here. So minus 1/2 e to the minus 0 squared minus 1/2 e to the minus b squared plus the limit as b goes to infinity minus 1/2 e to the minus b squared minus 1/2 e to the minus 0 squared. Okay, so this is where you want to actually get a number. If b goes to minus infinity, let me clean this up a little bit. Maybe it's just still not clear. You get minus 1/2 e to the 0 plus 1/2 e to the minus b squared plus limit as b goes to infinity minus 1/2 e to the minus b squared plus 1/2 e to the 0. Okay, if b goes to minus infinity, you're squaring it. So it's e to the negative of infinity. Okay, now you're not supposed to write this, but this is what is happening. So e to the minus infinity goes to 0.
Or, okay.
But you're not supposed to write like a good instructor will say, I don't want you to write that. That's bad math. I don't care if you write it or not, but like this second term goes to 0.
Or if b is negative infinity
and you're squaring it, it's positive infinity, but there's a negative in front.
So
that's where the negative comes. Now the b. Okay, so again, like let me write this out.
So it wouldn't be double negative, and then the affinity would be positive. Positive.
This is wrong math, but this is what you're doing. You're squaring negative infinity. So you're squaring negative 10 to the billionth, whatever number you like. That's positive, but this negative on the outside is still there because order of operations, you square before you negate.
Okay.
And this whole thing becomes 0.
Right.
And then this other one, it becomes negative 1/2 e to the 0 is 1. Is that okay?
Yep.
All right. On the right, it's kind of the same deal here. It's minus 1/2 e to the minus infinity squared plus 1/2. This infinity squared, when you square it, it's infinity. E to the minus infinity is 0. This becomes 0 plus 1/2. So your final answer after all of that work is negative 1/2 plus 0 plus 0 plus 1/2, which is 0.
All right. All right, let's do. Let's do hang on. The next couple are like the same.
Yeah, I can look here and try to tell you which ones are do something.
How about 16? Is that a fine one?
Well, so 16 is problematic because cosine alternates. You end up doing it the same way we just did, but it diverges because okay, so is it okay if I just do it from like 0 to infinity?
Yeah.
Okay. Because there's a lot of repetition in this one if you don't do that. So we'll make this 0. So this becomes the limit as b goes to infinity, integral 0 to b cosine pi t dt. Okay, so if we look at just the integral of cosine pi t dt, this is a U-substitution. U is pi t. Du is pi dt. So this becomes the integral of cosine u du over pi. So that's 1 over pi integral cosine u du, which becomes sine u. And u is really pi over or pi t. So this becomes 1 over pi sine pi t plus c. but we only care about this first part. The constant doesn't come into play here. So this is the part we've got to take away from it. 1 over pi sine pi t. So I'm just going to grab this line. I'm going to move it down. Hopefully I grabbed it there. Oh, bless it. Okay, there it is. All right. So this becomes the limit as b goes to infinity, 1 over pi sine pi t. And you're going to evaluate that from 0 to b. Is that clear? The integral is this down below it.
Yes.
Okay. So now you have to throw in the bounds, but you have to keep writing this limit business. 1 over pi sine pi b minus 1 over pi sine pi times 0. So let's do the one that you know. What is the sine of 0?
0.
0, 0. So 1 over pi times, so this is 0. The limit as b approaches infinity, sine pi b, this diverges or does not exist, or whatever notation your instructor wants to use, because the graph of sine, it oscillates forever. So I have no idea. Is it here? Is it here? I don't know. That's why this diverges, does not exist, whatever it is. If you get one of these, the whole thing diverges.
Right.
If you get d/e minus d/e, it diverges.
Okay. So if there's a diverge anywhere, d/e.
Yeah. If there's one bad place, yes, it doesn't work.
Alrighty. How about 23?
Okay. All right, so the graph of 3 over x to the 5th, it has a problem at 0. It's got an asymptote there. So it looks something like this. And that's how you decide which bound to make the b. So in the previous problems I did, I didn't even bother to mention that, but infinity is always a limit. Minus infinity is always a limit. But in this problem we're doing, there's no infinity. So you might think, oh, well, that's no big deal. You still need to do this limit business because at 0, there's a vertical asymptote at x equals 0. So that's how you decide. So it's the integral from b to 1 limit. This time, though, as b goes to 0. Not infinity, because it's going to 0. It's not going to infinity. Okay. Now this 3 over x to the 5th, really you should write it as, if you're still like not really super comfortable with these, write it as a negative exponent. So this is just power rule. This is that integral x to the n dx. You add 1 to the exponent, divide by the new exponent. So this is 3x to the minus 4th over minus 4th, evaluated from b to 1, limit as b goes to 0. And if we just clean this up a little bit, like the negative should go out in front, it's really -3. And then the x goes on the bottom, the 4 goes on the bottom. This is the preferred way of writing it. So it's the limit as b goes to 0, -3 over 4 to the power of 1 to the 4th, because I'm going to put the bound in now, minus a -3 over 4 b to the 4th. So you tend to want to do the one that like is numerical, but you really should do the other one first, because if the other one doesn't work, you don't have to get that number. So notice that as it goes to 0, this is division by 0, which is bad. That means it diverges because of division by 0.
So when you're choosing your limit, do you always want to choose the bottom?
No, it's whichever one is problematic. Problematic because when you put 1 in, 1 is fine, but 0 doesn't. And it's not here. It could be in the antiderivative that's problematic too.
Okay.
which is even more complicated to try to understand. But
All right.
you're moving into this part of calculus that's very much a little more gray, a little bit more not as like fixated on numbers. It's more
All right.
about these concepts of infinities and convergence, and you're like, whoa.
Yeah. Okay, so like 24. So you would choose 3 as the
That's right.
limit.
That's exactly
Can we do
right.
that?
Yeah, this one actually works, believe it or not, even though it probably doesn't look like it at first glance. But yeah, let me snip it in and we'll work through it. All right, so you just set it here. It's going to be the limit as b goes to 3, integral 2 to b, 1 over square root 3 minus x dx. Okay, so now don't know how comfortable you are with this, but you want to rewrite this. This is really 1 over 3 minus x to the 1/2 power,
Right.
which is really 3 minus x to the minus 1/2 power. You could do it as a U-substitution, but you don't really need to. You just have to account for when you take the derivative of your antiderivative, there's a negative there to deal with. If that's not clear, we can do a U-substitution. But like what I was trying to get you to see is like you just want to add 1 to this. So it's minus 1/2 plus 1 over minus 1/2 plus 1. But because the inside function has a chain rule derivative, you have to put a negative on the outside, whatever it is.
Okay.
And if that doesn't make sense, let's just carry it through, because you eventually have to get to where you see this. This is on the bottom, this becomes 1/2.
Right.
So that's negative 2, 3 minus x to the 1/2. So this is our answer. If you didn't put the negative, like let's just say you didn't put the negative, which is what I keep trying to get you to believe or buy into here. When you take the derivative of this last line here, you're supposed to get back to the original. Okay, and I want you to see that because this is important. So it'd be 2 times 1/2, bring the 1/2 down, 3 minus x to the minus 1/2. But then what's the derivative of the inside function? There's a negative. Do you see that?
Yep.
So that leads to negative 3 minus x to the minus 1/2. But if you go back and look at our problem, do you see how there's no negative there?
Yep.
That's why you have to throw that negative in.
Okay.
So you end up getting negative 2. And I'm just going to rewrite this as square root 3 minus x from 2 to b.
Could you explain where that the 2 came from, just real quick?
The dividing by negative 1/2 plus 1, dividing by the new exponent. So the new
That's
exponent is 1.
Multiplying by 2.
Yeah, well, it ends up being 1/2 on the bottom, but then you divide, becomes the reciprocal.
Like, yeah, like dividing by 1/2 is the same thing.
Yes.
Okay. All right. I'm good with everything.
Okay. So yeah, like we got to keep writing this limit stuff, and you're just like, as a student, I don't know, maybe you don't even think much about this, but like I was always worried, just seemed like, is this thing even gonna work? Like I did all this work and like I don't know what's gonna happen here.
Yeah.
So I know you would tend to go to the number, but you should do the b part first, because if it doesn't work, the number is irrelevant.
Right.
Negative 2 times the square root of 3 minus b. Well, b is approaching 3. So from your very first, calculus class, to at least try putting that in. Is 3 minus 3 okay? Yeah, that's 0. Is the square root of 0 okay? Yes. This is just 0.
You just can't have a negative number underneath.
Right. Or you can't divide by the square root of 0, because then it's undefined.
Yeah.
Plus 2 square root of 1. So this equals 2.
And that's converging.
Yes. If it approaches a number, it converges.
Okay.
So by the way, what you're doing right here is what's called the integral test, which you'll learn about convergence and divergence in a future section. And one of the tests is to just straight integrate it. If you get a number, whether it's 0 or not, it converges as long as you get a number.
But is 27 a difficult one?
Nope, nope. We
That cube
can
root just kind of haven't
we can
seen
s-
one.
we
I
can
haven't seen
set
one for a cube root.
we can set it up, and you can decide, of course, how far you want to go. Because there's no infinities, you have to figure out the B in this one. So the B is when the bottom is 0. Do you agree with that?
Yes.
So what X value makes it 0 on the bottom?
1.
1. So it's the integral from 0 to 1 over the cube root of x minus 1 dx plus the integral from 1 to 9, 1 over the cube root of x minus 1 dx. That's your first thing. You break it up because those vertical asymptotes you have to do this way. There's a vertical asymptote at x equals 1.
Okay. So when so
because
when,
because 1 is between 0 and 9. Like if this wanted it from 2 to
Right.
9, you wouldn't think twice about it.
Mhm.
But because there's a discontinuity, that's the right word I was looking for, because there's a discontinuity, that's why you have to break this up. Now your B
Okay.
is that discontinuity. Oops, that wasn't you. There we go, that's you. Okay, so your B here is the limit as B goes to 1, integral 0 to B, 1 over the cube root of x minus 1 dx. Now, because these have the same B, we can actually get away with not writing it again. Okay, so now you got to be able to find the antiderivative of this.
Basically, you're just finding the area of one part of the interval and then
Integral, yeah.
Okay.
And then one part of the interval, yes. Like, and it's got to converge. They got to
Right.
both converge.
Okay.
So I think it's kind of weird that it can converge at an asymptote. Like if conceptually, like that thing goes up forever, but somehow we can find the area. And there's also kind of, I also have a problem with this over here. Like it kind of bothers me. I don't think much about it anymore, but like if you think about you're going out forever.
Yeah, right.
And like my understanding is you're doing something with the military. You're like, planes don't fly forever. They run out of gas,
Yep.
missiles. There's, I don't know. This probably doesn't apply to anything that you're doing in that world ever, but it does bother me. But this is just a math class. So.
Yeah.
Okay. So the antiderivative of this, if you rewrite the cube root of x minus 1, it is 1 over x minus 1 to the 1/3 power.
Right.
Okay. And then if you bring up that 1/3 power, it becomes negative 1/3. So this is just a power rule. You're going to add 1 to the exponent and divide by the new exponent. Okay, so just kind of follow up from the last problem. It becomes x minus 1 to the 2/3 over 2/3, but then you flip it.
Okay.
So this becomes 3/2 x minus 1 to the 2/3 power evaluated from 0 to b. Oops, we actually can do the whole, I don't know, plus same thing over here, 3/2 x minus 1 to the 2/3 power b to 9, the limit as b approaches 1 for all of this. So then you got to substitute in your limits. So it's 3/2 x minus, I'm sorry, b minus 1 to the 2/3 power minus 3/2 0 minus 1 to the 2/3 power plus 3/2 9 minus 1 to the 2/3 power minus 3/2 b minus 1 to the 2/3 power. And just to be clear, it is not okay to say, oh, there's a 3/2 here and a -3/2 here. I can just
Cancel them.
cancel them. That's like fail the course stuff in my book. So, but you might find it works out nicely. Like when you put 1 in for B, well, this does become 0.
All right.
And over here, it's the same thing because it's 1 minus 1 to the 2/3 power. 1 to any power is I'm sorry, it's 0 to 2/3 power, so that's 0. Okay.
Right.
And this is 0 here. Now they do cancel out because of that, but not because they were the same. You got to do the limit. This is -1 to the 2/3 power. So it's the cube root of -1 squared. So -1 squared is 1, cube root of 1 is 1. So this is -3/2. 8. So this is the cube root of 8 squared. 8 squared is 64. Cube root of 64 is 4. 3/2 times 4 is 6. And you just add those together.
That's your answer.
That's your answer.
Okay.
But the instructor is grading you on notation most of the time.
Yeah, she has us writing out everything.
Yes.
Honestly, that's all I wanted to go through.
Great. Well, I'll send you the notes here shortly.
Alrighty.
If you don't mind, just hang on just a moment here.